We'll do final editing and we'll upload it to the website when we'll finish the training. So just for you to know. But you know what? Yeah. We are recording and we'll send you the link. Actually, the first one we already have, so we can start sharing very soon. Okay, so I think we can start. Let's not waste time. I hope all of you had time to practice a little bit of what we did in our last meeting. But what I want to take you now is just as a quick reminder, but let me start by sharing my screen. See, someone else wants to join. Okay. So, as I said, so can you see my screen? Adam, can you see my screen?
Yes, sir.
Thank you.
Yes, I can see.
Okay.
Yes, I do.
Good.
I can see.
Okay, good. So, you know what? Let me change the resolutions. We have the same problem of very high resolution, so you can see better. Okay, so in our former session, we learned how to use ZWCAD Civil. We learned that there is something that we call project, which is the overall environment of the software, the container, where we contains also a DWG of the project, and a lot of other files, TCO, DCO, ROD, which are associated with the project. This is the reason why each project, usually we put it in a different folder. We learned that there are two important projects, one named no name, which is the one which we use when we open the system. We don't work in no name. We open a new project or open an existing project, but we don't work inside no name. We also learned on prototype. We even in prototype, we can do, or we can define the prototype of how we work with the system. And we learned how to set something that we call global scale, which is the text height or the text size, which is adjusted to a certain printing scale. And we learned how to choose which of the ZWCAD environment, drawing environment we use. For example, if we have two ZWCAD in our system, one is 2020 and one is 2021, we can choose which one we want the ZWCAD Civil to work with. Speaking of the same, I explained that ZWCAD Civil usually works with the last 3 ZWCAD versions. It means that this current version 10.2 can work with 2021, 20, and 19. Usually when ZWCAD will release or about to release ZWCAD 2022, the new ZWCAD Civil will support this one and then backward 2021 and 2020. Then we went into a small lesson where we learned that the text editor here on the lower left corner, we can enter coordinates, we can type coordinates, we enter the point name, the easting, the northing, and the z. We also learned we learned that whenever we do change in the coordinates list and we hit the refresh button, which is upper left here, the system scan the list and update our drawing accordingly. We also learned that we can go to the pick, which sits here, press pick, go to the drawing and pick a point. Then automatically it will appear in the list. And once we refresh, you can even see the name. As far as I remember, I talked about some features. I remember talking about blocks and how to work on columns by the block. We talked about this one, zoom to point. If I click on a point and click on the zoom, it will put it in the center. We learned how to save the points from this coordinate editor into a file, which can be then uploaded into a GPS or a total station. The next thing that we did, we said once we have the coordinates, we can use the topography contours, and on this window, specify the vertical interval between contours and press apply to get the contours. We learned that once we create the contours, the system do triangles. We talked about it, what we call tin, which if we want to see it, we just hit here on the short triangles and apply again. And that shows us how the system actually creates the contours, or in fact, what it also creates is a 3D surface. And to view this 3D surface, we use the design section between 2 points to be able to see the sections. So this was the end of the discussion, and this is what we learned. Does anyone have any question about what we discussed so far? Because from this point going forward, I'm going to the next subject. Do you have any question? Feel free. Any of you? This is the time to ask, even if it sounds like a stupid question, there's no problem. No, at the end of the day, there are no bad students, but only bad teachers, which is true, by the way. Okay, I do hope that the silence doesn't mean that you don't understand what I'm talking about, but let's see, let's continue and let's take it from here and let's see how it goes. All right. So without further notice, what I will do now, I will show you a short practice, and I want you to practice the same. I will do it first, then you practice it in your own system, and this would be the base for continuation of our discussion, which is what we call the border problem. The border problem on contours. The border problem on contours, what I'm talking about, very soon you'll know. So what I'm doing now is talking about the border problem, the border of where the contours will go. In fact, the problem, let me try to explain to you. Let's assume this is a road. Okay, this is the center line of the road goes like this in the center. And this is the border of the road. A problem is that once we create the contours, the system will don't know, unless we define it to it, how to end the border here. Even if we have points, the system automatically interpolates from this point to this point. It's very vague in this way, so let's do a practical thing and you'll see it by yourself. I'm starting by File, New Project, and I will put it again at my C projects. Let me open a new one. I will call it Beginners 4. I'm going inside and I'm calling it Beginners 4. So I open a folder with Beginners 4. Good. Now in the CivilCAD, I will do zoom to window, and I create a window that starts from 1000 to 1000 to 1500 to 1500. Okay, so more or less my coordinates now are somewhere. There's a window here of almost 500 meter by 500 meter. And what I'm going to do, I'm using the peak here on the right corner. And let me put, let's assume that we have a road which we surveyed. We got it from the field. So let's create these coordinates from the field. Now, let me remind you, usually to read it, we just use this lower left button here. This is what we did in our format training. But now I'll create it with you. So let's say the first survey was 1 point here, 1 point here, and 1 point here. Okay? And the surveyor continued and surveyed another section here. And the surveyor continued and surveyed another section here. You see the coordinates below. And he continued and surveyed another section here, and another section here, and another section here, and another section here. Good. So you see I did some kind of like a snake. This is a curve and I'm surveyed it. Let's refresh. Let's see. These are the points. Okay? These are my points. And let's give them some elevation. So these three. Let's start with 1005. We'll go up, come here, and let's say this is 100, and the next one, 1006, is also 100, sorry, 100, and this is also 100. So these three are in the same level, 100. Let's see, okay, 100, 100, 100. Let's go to the next three. 1008. This will be 101. The one in the center will be 101.5. And this one will be also 101. So this one is 101, 101.5, 101. So what I'm asking all of you, I'm leaving my window open. I'm asking all of you to practice the same. Open a new project, use the peak. First of all, zoom from 1000 to 1500, create a window here of 500 meter to 500, more or less, it's not so important. And then use the peak here to pick 1, 2, 3, 1, 2, 3, 1, 2, 3, like I did. Continue like this, I'm waiting. If you have any problems, I'm here. I'm here to help. So take your time. Just create it. Let's take the next 5 minutes to practice this. Please, all of you. Guys, how is it going for you? Sheena from Infrasys, is it okay?
Yes, I'm working on it.
Good. Okay. Again, any problem, feel free to ask. These are the basics. Once you get this one, you see that more complicated thing will become easier for you. But if you don't get the basic, then later on, when I'll go to more sophisticated things, this is where the problem will start. Okay, anyone needs more time or can we move forward? Feel free, if you still didn't finish it, let me know. Don't forget to give heights. I start with 100, 100, 100 here. I continued with 100, 101.5, 100, 100. By the way, it's not so important to me which elevation you intend to give. And I want to continue with here, 1011. Let me put it, okay. All of you, continue to give heights along the road. You can use my height or you can use your own height. It's not so important. As long as you make it reasonable. I mean, you don't do, I don't know, 10 meter and then 1000 meter. Use more or less the same elevation all along. But create some difference, otherwise we will not see contours, it will be flat. So you can see on my screen, I've added more. Here I put 102, here I added 104 and put 104.5 here. And here the last one. And I'll call this 106.3, this 106. And this 106.5 to this one. This one will be 108, 108.5, and this is 108.3. Let's see. Okay, and the last one, 110, 110.2, 110.5. Okay, I finished. Please, all of you, give elevation to all your points. Please, can I have your attention for 2 minutes? Please, all of you, look at my screen. Please, everybody, look at my screen. I hope you look at my screen. Look at my screen. I want to make the text bigger. Now, let me remind you, it's set to be printed at 1 to 250. I press options here, have the button here with the hand holding a paper, and I change the coordinate scale, make it twice bigger, 500, and then refresh. See, now it became bigger. In fact, we can even take it bigger. $1,000. Okay, now I hope you can see what I'm doing. So all of you, please do what I did. Okay, I will ask it this way. Does anyone need additional time? Is anyone not seeing the same as I see in my window? Silent. Jimmy, did you do the same? Is it okay by you?
Yes, I'm fine.
You are fine. Fine, it means you have the same situation on your screen?
Yes.
Okay. Gian, do you have the same? Gian, I think I pronounced it correct. Mr. Ignacio. Gian Ignacio is not with us. Okay, he's writing. Yes, my mic not working. Okay, so you're okay. Lodi, can you follow us? Is it okay by you?
Yes, could you repeat the option?
The options, what I did.
Yes.
I went
Yes,
here to the lower
yeah.
screen.
Oh yeah. Okay.
Click it. Change the
Okay.
scale. Press OK. And then
1,000, yeah.
okay.
Okay. Okay.
All right. Let's continue. So this is the window, and now I want to create contours. So I'm using what we did before: topography, contours, intervals in the right window. Let's make it 0.25, and I press apply. Okay, this is what I got. I hope you got something similar. I hope you've gotten something similar. Okay, these are the contour lines which I've gotten. But look at the problem. I know that the road ends here, along more or less this line. You see? but the software doesn't know it. So the software did an interpolation between this point and this point, and this point, and this point. Although the interpolation should stop here. We call this the border problem. In fact, the software will always go to something that we call convex hull. The convex, i.e., meaning always look for the maximum area of coverage. It's a very known problem on team software that does triangulation. Let me show the triangles. You see, these are the triangles. And all these triangles, this one, and well, this one is okay. Yeah, this one, we don't want them. Now, this is the problem. I hope the issue of the border problem is well understood now. So again, the problem of the borders is where our solved area is not convex. It has like a road, it's go like this. Or in other cases, you'll see it as well. And the software automatically interpolates to the maximum coverage area. Although we know that the contour lines ends up here, the software continue with additional triangles, which we don't want. So this is the border problem. How do we solve? What is the solution? There are two ways on how to tackle this. One is to go and physically marcate or demarcate the borders for the software. We'll soon learn how to do it. But there's another solution, quicker solution, which in 80% of the situation works. How do we do it? We have this value here, maximum interpolation length, This value tells the software, you do not create interpolation between points which their distance between them is above the maximum interpolation length. What does it mean? I created points here along sections, which is what our surveyor did. And usually the distance here is more or less, let's see, what is the distance from here to here in 2D? 40 meters. So here it's also 40 meters. Here maybe it's longer, 50 meters. Let's see, outside here. Oh, it's almost 60 meters. So I'm saying to myself, software, I know that I as a surveyor don't want to create interpolation between points which are longer than 60 meters, or let's say 65 meters to be on the safe side, but I can play with it. Let's say 65 meters, and I press apply. See what happened. You see what happened? All the points, all the triangles which have an edge which is longer than this value, 65 meters, were removed. So this triangle, or this triangle, or this triangle, all the triangles that has an edge with more than 65 meters were removed. Now we see that there is a small triangle here. Either we leave it as it is, or we fine tune it. It's not so important. In fact, I'm not sure what is correct. We can leave it as it is. But the principle is maximum interpolation length. Each triangle which is longer than a specific length, this is what we do.
Okay.
Questions about what I just explained? Any questions? So again, the problem is what we call border problem. Is that the software creates triangles with an edge which are longer than what we want. The solution goes to the maximum interpolation length, enter a value and press apply and see the result. In fact, I can even play with it. I can, yeah. So, for example, in the maximum technical length, let's put 80 and press apply. Okay. You know what? Let me pay 110. You see, now the software added this triangle because the distance from here to here is probably shorter than 110. So we can play with it until we find a good solution. That's fine. That's fine. Let me remove the mounted interpolation length and press apply, meaning it's not applicable. So we finish with the border problem. Now I want to talk about another thing that we call it, we name it breaklines. Is anyone in the audience familiar with the term breaklines? Maybe the people from Infosys. Have you heard the term breakline? Any of you? If we go beyond the limits, does it not calculate or it shows zero? What is, okay, there was a question. If we go beyond the limits, does it not calculate or it shows zero? It calculates. You mean, okay, there's no limit. What do you mean? Here, it would be zero. If this is the question, I'm not, faith, I'm not sure I understand, but if you talk about here, it would be zero outside. Or actually, it's not zero, it would be calculated because zero, there's no zero. Zero, it's the sea level. I hope this is what you meant, was a question. Okay, anyhow, let's continue. And I want to talk about something that we call breaklines. Are you familiar with the term breaklines? Anyone? Maybe the Infosys people? No, none of you. Infosys, Gian, are you familiar with the term breaklines? No, none. Okay, good. I've heard it before, but not really sure. Okay, let me fine tune it. This is very important. In fact, if you don't use it properly, you got a lot of problems in your sections, in your volumes or whatever. So this is my road. Now I will do something. Let me remove the triangles so it will be clearer. Now let's assume, you see this is the edge of the road. Let's assume that here at the edge of which road, here, there are additional points we were measured here on the top of a cliff. You know what, maybe I will try to explain what I'm doing. Let's assume a section that goes from here to here. Let me show you the road in profile. So this is the road. And then let's assume this is a cross section of the road. And from here, let's say I have like this and like this. This is my profile of the road. I hope you understand. This is the section of the road. This is the asphalt and there's a cliff here. So this point is the point here. This point is the point here. This point is the point here. And I have two additional points here on the top and here. Let's put them inside. Let's go back again to the topography coordinates. I'm clicking pick and I will add another point. One here, which is this one, and one here. So another one here, another one here. Okay, I have added 2 points. Here and here. And again, 2 points. Here and here. And another point. Here and here. And another point here and here. I hope you can follow what I'm doing. So I've added points here and here, which are this point and this point. And again, this one and this one. So here, this is 100. Here it's supposed to be much higher, right? Like 5-meter jump, because it's a cliff. So let's look for 1026. And I'm putting here 105. And I'm going to 127, and it's a little bit higher, 105.2. Am I clear to what I'm doing? What I'm trying to illustrate? Can you follow? Guys? No
Yes.
response. Can you follow?
Yes, Super.
You can. Hatik, can you follow? Hatike. I hope sorry if I pronounce it wrongly. Yes, you can. All right. And Adam is okay as well. Right. So I've added 2 points here, 2 points here. And again, here there's a jump. So here we put 5 meter. Let's put 5 meter as well here. So I'm coming here. And this is 101. This will be 106. And this is 106.2. And I press refresh. Okay, these are the 2 points which I measured here. And here this is 102, so this will be again 5-meter jump. It doesn't have to be the same. Let's say 6-meter jump here. So this will be 108, and this will be 108.5. Just for illustration purposes. Here. And the same goes here. This is 104. Let's put 4 meter here. So 108.5. And this one will be 108.8. Okay. So this is what I did. I'm a surveyor and I surveyed 2 more points on the top of the cliff. I finished with my road. Then I climbed up, and this is only 5 meters, it's not that high. And I surveyed 2 points here and continued 2 points here, 2 points here, and 2 points here. And I came from the field, I loaded, like open it from here, like we did for sample 7, load the coordinates, press refresh. So the coordinates, I'm okay. I'm going to topography contours like you did. And enter 0.25 and press apply. Let's see what will happen. Oh, and this is what I got. Here it looks fine. See here. Okay, here we have a problem. I think it's because the triangle goes from 127 to 1005, so we can fix it by the border problem. Here the cliff is okay, you see? It's a cliff. Cliff is okay. Cliff is okay. Cliff is okay. Oh, here, somehow I have a problem. Now, very soon, I will show you that what we have here is what we call the breakline problems. See what happened. This is crazy. It doesn't look natural. You know, the cliff looks okay, but somehow here, it messed up. Why this is happening? And this is the question. Now, obviously, if the contours are not okay, when the surface is not okay, and when the quantities will not be okay, and the design of the road will not be okay, this is not reality. Because there's a cliff, and the software did a mistake here. Now, what is the reason? Let's do short triangles. Okay, first of all, you see this triangle, we can move it later on by the border problems. But here, see, everything is okay. The cliff is okay. Yeah, but see what happened here. Instead of the triangles to end up along the cliff, this is the end of the cliff, sorry. This is the end of the cliff. From here to here. I hope you can, this one, let me give it a color. What can be good for us? Yellow. Okay, you see it? The one which I highlighted. This is the end of the cliff, right? Sorry, no, not this. Yeah, this is the bottom of the road, and this is the top of the road. This is where the cliff is, between these 2 points, these two lines, right? This is supposed to interpolate to this one, and this is supposed to interpolate to this one. I hope you got it. This one and this one define the cliff. In fact, it's the same like here, but here is okay, yeah. The cliff is from here to here, right? This is also the cliff, but here it's okay. Here somehow it's not okay. And why it's not okay? Look what happened to the triangles. The software doesn't know that there's a cliff here. It doesn't understand what we know. We know, we are the surveyors. We came from the field. We came from the field and we know that there's a cliff here. But the software doesn't know. So what the software does, it does an interpolation between this point to the nearest point. Where is the nearest point? This is not the nearest point. Instead of creating triangles here, the software created interpolation from here to here. And this is the source of the problem. From this point to here, there is a triangle, where in fact we want the triangle to end up here. We call it the breakline problems. How to sort it out. Now, if I'm a surveyor coming from the field, I will not know where the software will give me a problem or not. But I know, because I'm the surveyor, that all the points which I surveyed here are at the top of the cliff. I know. The one that goes from 1026, 28, 30, here are at the top of the cliff. And I know that, sorry, at the top. And the bottom of the cliff is this point. 116, 113, 110, 17. This is the bottom of cliff. This is the top of the cliff. I know because I surveyed it. Either I mark it in the field in a serial number or give it a code or whatever, but I know. So when I come to the office, I download all the points, refresh, get the points. Then I'm going to topography, lines. Again, topography, lines. And what I do, either I enter the serial number of the points which I know, which create the lines of the bottom and the top of the cliff, or I can even locate them here. So it depends. If I reorganize myself in the field and I know the number, I have the sketch which I draw in the field, I can put it inside here. I know that this is 21, 26. So I'm clicking here, 1026, plus enter. Okay, and I continue. 10, going again to the right, 1028. You see, there is a line. And I continue to 130. I go here, 130, and press enter. And I continue here, 132. 132. And the last one will be 1019. No, sorry. This is the last one which I solved on the top. 32. If I finished, yeah, all these points represent these points. When I finish, I just finish this one, right? And I click here, set points list as a line. Click on it. Now it's a line. It's the first line in the list. Now I want to create the second line, which is the one on the bottom. This one in the section, here on the bottom. I press new. I can start typing the names, 1007. But I can also go by graphics. So I press the locate here and go. This one, you see it, 1010. This one. This one. And this one. I can continue here, but it's useless. And when I finish, you can see in the command line, press set, S. That's it. So I have number 1 and I have number 2. You can flip between them, 1 and 2 in the list. So I have 2 break lines, one on the top of the cliff and one on the bottom of the cliff. If I refresh, by the way, it will become a 3D polyline. See, this is it. T break lines. If you see, it's a 3D polyline. You know what I'll do? Let me go to layers, T break line, and give it bed maybe. No, what I did it for the triangles. My mistake, I did it for the triangles. T break line. Let's take this one and give it yellow. Okay. You see the 2 lines here and here? Let's do it again. T break line, T break line. Okay, now you can see. So there's 1 break line on the bottom and 1 on the top. But still my contour lines are still in messy. So what I do, topography, contours, and I apply again. Now the software will take under consideration the break lines. You see what happened? All the contours arranged here. Everything is okay. It's arranged. Now we are okay. In fact, let's summarize the issue of breakline. Breakline is a mathematical problem, but it says that 2 points are interpolating and we don't want them to interpolate. The solution is to create a breakline, a point, which breaks the interpolation. It's the software. Point on one side of the breakline does not interpolate with the other side. The interpolation is to the breakline and from the breakline. In practical, in the field, we create breaklines. Since we don't know when to interpolate or not, we create breaklines when we have gaps or sharp gaps. I'll give you an example. This cliff, but it can also be in something that all of you know. Let's say this is the road. Here, usually what we have is the sidewalk. Right? This is the sidewalk. It's only 15 cm or 20 cm, depends. 20, 25 cm. But also, if we don't markate this, it will also give us problem. It will give us wrong contour lines. Guys, I want you to try and practice this. It's more complicated, but it's very important. By the way, if I do design section now, what I did in the first lesson, design section, pick a point from here to here, you see? This is the cliff. And this is the road. So guys, you can try by yourself. I want you to try practice it. Again, think like a surveyor. Go to the topography coordinates. You start by adding points near the road at the end. 1 and 2, 1 and 2, 1 and 2, 1 and 2. Add points at the end and then create contours, and then go to topography lines. Start with the first line. Use either locate or either enter the number of the points. Create the first line. When you finish, press this button, then go to the list, create a new one, and continue. Try it by yourself. I'm here if you encounter a problem or you forget anything, but start with the points. Start by adding the points of the cliff. Take your time. We're taking 8 minutes for this practice. אבל אני בעד לעלות ל-110. Anyone needs help? Could you do what I did? Did you succeed to do what I did? Jimmy, Could you succeed to do what I did?
What?
Could you succeed to do what I did?
No.
No, you did not.
Yes.
Okay. Can you share the screen so everybody will see the challenge?
Sorry, I want to start from the beginning.
Sorry?
I want to start from the beginning.
Which beginning? Which of the beginnings?
That's from the borderline.
You know what? Lodi, did you succeed to do what I did? Lodi?
Yes, I
Did
start.
you?
Yeah, I start from in the middle. I start to redraw the point
You are
because
still
the
there.
line is different. Yes, the contour line is different.
Okay. Okay, what I can do for you, okay, please everybody have attention on me. All of you, please have attention on me.
Yes.
All of you, please, everybody, attention, attention. Gian, Lodi, Nilo, Marina, Hatik, Adam, all of you, please, be with me. Sheena. Okay, okay, yeah. What I'm gonna do now, instead of you to continue this way, I'm gonna share the coordinate points here. So all of us will be in the same page. How do I do it? I go here on the save, you see, save all data current block. I want to save all these points. I press save here. And I will put it on my desktop. I will call it points for beginners, day 2. Okay. And I save. And I give it an extension point XYZ. So let's see in the desktop. Here it is, okay? Let me open it with, you know what, instead of XYZ, let's change the extension, call it TXT. It'll be easier, TXT. Yeah, here it is, this is the point. Now what I'll do, I will share these points with all of you. So on the chat, I'm adding this point to the chat, please. So just have a look at the chat. You should get it by everyone now. All of you, please take the file which I shared with you on the text. It's a very small file. It's 2 kilobytes, 1.5 kilobytes. Please load it and you can place it on your desktop. It's not so important. Or in a folder. Just load it and put it on your on any folder, whatever. Then all of you, please start a new project. You do it by start your ZWCAD Civil, go to File, New Project. Open a folder for it like we already did before. I will call it Beginners, Beginners 5 and Beginners 5. Okay, and open a project. Then go to the lower left corner, press the most left button, load from text file, load from file, press here. Go to where you place the file which I've given you, the text file. I'll put it on my desktop and read it. You see now it will appear here. Then refresh and don't forget to zoom to extents. Here it is. Now you should have the same file which I have. Then continue by creating contours, topography, contours, and let's make it 0.25. Okay, all of you do what I did just now. Be in the same position where I am just now. 3 minutes, guys. It's very simple. Take the file which I shared with you, open a new project, load the file from the lower left, refresh it, and create contours. Very simple.
Where is the file?
I sent it in the chat. You should see it in the chat. In the chat of the Zoom. Did you see it? Jan, can you see it? Lodi, Atik, Adams, Lodi, not yet. What about the rest? Jimmy, can you see the file?
Yes. Yes.
You can.
Yes.
Atik, you can? Yes, text file, right. Jan, yes. Andre, yes. The text file, right. Take it, place the text. No, where is the file? Adam, in the chat, move up. You should see it. Points for beginners, underscore day2.txt. I'm using browser for Zoom, but you don't have chat? Even the browser opens a chat for you. No, it runs an application, unless it's pure, yeah, even in, yeah, it's supposed to show, I don't know. Everybody, text the file, place it somewhere. You can press it on your desktop, go to ZWCAD Civil, start a new, okay, let me write it down. 1, load the text file and place it on your desktop or somewhere else. It's not so important where. 2, start ZWCAD Civil. 3, file, new project, open a new folder.
Oh yeah, good.
In the folder, enter the name of the project. You can call it beginners 10. Number 4, from the lower left corner, load the text file. Yes, I can reshare the text file. No problem. 1 second. 1 second, soon I'll do it. From the lower left corner, load the text file by pressing the button. 5, press refresh. Left. 4 from the right. 4 from the left. 6, zoom to extents. 7, topography. Contours, 0 intervals. Yeah, you have the full instruction in the chat. Those of you that just need this tool. So just all of you, please be in the same page, or you will have the points so we can continue. Guys, all the explanations is in the chat. Should be in the same position like I am.
Yes, I am.
Okay, now, topography, lines. Let me do it again. Please listen, please follow my screen. Topography lines. On the right-hand screen, I'm starting with line number 1. You see, this is line number 1. This is the list of the lines, and this is the content of each line which is highlighted. This is line number 1. Locate this point. See? 126. This point. This point. This point. And I finish by pressing S and enter in the command line. Then I have my first line. Then I start a new line. I press this button, new line, locate, 1, 2, 3, 4, S and enter. So I have 2 lines. I'm going back to topography contours, apply again. Here it is, it's organized. So this is what I'm asking you to do. Exactly the same. Let me write it down for you. Topography line. In the right window, start with the first line. Press locate. Go to the drawing and mark and select the points along the first line. To finish, press S in the command line plus enter. Then in the right window, press the new line button, lower row, and repeat the process for the second line. 11, topography, contours, topography contours. You have the instruction, try to do it. If you have question, I'm here. Sorry? Someone is asking something? Guys, if you have question, I'm here. It's very important that you succeed to do it. And it's very okay if it's not working in the first time. You have to practice like everything in life. Okay, I want to continue. So we saw the problem of the break lines. Now, what I want to do is to use the maximum interpolation length to remove this unnecessary triangle. So on the maximum interpolation length on the right, I'm doing the apply.
Ya, garis ini dulu nih, batas.
Lodi, can you okay, good. Okay. Okay. What I've done here, not 60, let's make it 70. 70 meter to ensure. Sorry. Okay. And use 70 meter to remove all unnecessary triangles here. So what I did, I went to topography constants and make 70. Good. So this is my road. This is my area. Now, let's assume that along this road, there was some excavation being done. Meaning there was a pit hole which was excavated here, a big pit. In this area, there was a pit along here. And I want to calculate the volumes between this, which was before, and the new surface, which is now. So again, the issue now is earthworks, earthworks calculation. We are now talking about earthworks calculation. So everybody, the issue now is earthworks calculations. This is our issue now. This is what we're going to talk about now. Up till now, we learned how to create a surface. I'm a surveyor. I measured this existing ground level. This is the existing ground level. And then the bulldozer came and did some earthworks here, cut and fill here. Let's say they cut here. I'm going back to the field after they finish the work. I'm resurveying the area and I have the new coordinates file of this area. After the cut and fill has been done, meaning we have the surface before, now we'll create another surface which is after. And then we'll tell the software compare the two surfaces. So again, imagine this is one surface, right? Now we will take points of what happened after we finish the earthworks. We create a surface out of it. And then we'll tell the software give us the volumes between these two surfaces. How to do it? Okay. So first of all, I went into the field, I surveyed this point. All of you have it already. I created the contours. I have the 3D surface. I'm happy. The contractor with the bulldozer went into the field, did their excavation, and they called me back after 2 weeks to survey again, to calculate the volumes. I opened my software. I opened the same project. But now instead of going to the topography, I'm going to design. Up till now I had topography. Now I'm going to design. And I'm going to design coordinates. Now see, this is a new list. The former list exists here. Topography, coordinates. Here it is. But now I'm going to the design coordinates. It's a second list. Now let's say the points which I surveyed are, let me create one for you, pick. One was surveyed here. Another one was surveyed here, another one surveyed here, another one surveyed here, another one surveyed here. The good thing is that the software knows how to calculate the 3D because this is a surface, so already I have the elevation. So let's say this is the top of the pit. Now let me survey the additional point. I surveyed, this is the top of the pit which I surveyed. Now I went into the pit and I surveyed the additional point in the bottom of the pit. This is the bottom of the pit. And okay, this, all of this is along 100. And this is 100, this is 111, this is 101. So let's do it like this. These points which are here below, I will take them 120, 25, and 24. 120. I will take it to be 5 meters below, make it 95. 115. No, 25. Is also 95.3. 24 is already a little bit higher, 96. By the way, I hope you noticed that the system added the points in a different layer. If this is civil, this is in a different layer. They call the software, named it D point, the design point, automatically, a different layer. And let's assume this one, 21, 22, and 23 are also 96.5, 96.5, 96.7. Okay, so I have the points in the bottom and I have the points on the top. And to be on the safe side, like I did in the topography, I'm doing topography lines, and I will create a break line in the bottom, and on the top I don't need it, it's the outside. So I go here, this is the bottom of my pit. This is the bottom of my pit. I can put another one on the top, it's not so important. And if I go to the topography, design contours, again 0.25, press apply. You see? These are the contours of the pit. So we have existing ground level and we have design ground level. We have two layers here, two surfaces, one surface and the second surface. So this is the bottom of the pit, these are the cliff of the pit, and this is the top, which is still the ground. Let's see if I do something like this, I'm supposed to see sense. Sorry. Yeah. What's going on? See, here it is. This is the top of the existing, and this is the design. This is my cliff, my pit, sorry. If I change it to 1 to 5, it's better. Okay, this is my pit. This is a section of my pit. And this is what we have here. I hope you follow. So what I did in the topography, I did in the design. I went to the design coordinates. In this case, I built the file, but you can read it also from the total station, from the survey instrument, from the GPS. Then refresh. Automatically, it would be loaded into a new layer. Then you go to design, contours. On the right, you enter the intervals, you press apply, you get the design coordinates, or you can even go to design lines to define design breaklines. I hope you got it. So I have two surfaces, this surface and this surface. And I want to compare the volumes between these two surfaces. So I will know how much, in this case it's only cut because I've cut the surface here. How much did I cut here? So we started with topography. When we went to design, now we're going to Earthworks. Earthworks. Earthworks, general. And there's a window on the right. If I press apply, see what I get. General Earthworks. Cut volume, you know there's no fill. Cut volume is 6,131 cubic meter. So again, the software took the surface of the existing ground level, the surface of the design, in this case, it's what we call as made, is what was happened after the excavation. We created two surfaces, and then we went to software Earthworks General. Give me the volumes between these two surfaces, and this is what I got. 6,131.82 cubic meter. These are the surface, the volumes difference between the two surfaces. I hope this is clear. I hope this is clear. Let me repeat the process. We start with topography. We loaded the points. We create contours, but then we saw a problem. We saw two problems. First of all, we saw that here we need to define breaklines over the cliff. So we went to topography lines, one breakline and second breakline. And the second thing that we saw is the maximum interpolation of the border problem. So we limited it. And when we got the contours. Then we went to the design and did the same this time around for points of the design. But to make sure that the bottom of the pit is well defined, we went to design lines and defined a line along here. And again, design contours and create contours. Then we went into Earthworks General, we press applied, and we received cut and fill volume. In this situation, only cut for this pit. What I'll do now, let me save the design points and share it with you so you can practice it later on. Save. Let's call it points to beginner's day. In this now time, I will call it design points. And let me open the chat. Okay, so I shared with you the design points. You can try to practice it now or practice it later, but let me finish the session. I've created the topography coordinates and created the topography contours. I've created the design coordinates and created the design contours. I went into Earthworks General and I got, by pressing apply, I got the volume. The volume say 6,103. This is very accurate, but Someone can come and say, guys, tell me, Shlomi, how did you get this cut and fill? How do I know that the software is correct? I want to check it, inspect it. So what I'm going to do, I'm telling the software, take your calculation and break it down to show us how did you get this to this figure. Give us a grid, and give us a grid of 5 meter by 5 meter. And I press apply. Let's see what happened now. Okay. Software created a grid. You see the text in the grid is too big, so I'm going into the options in the grid on the right, general, and change it to smaller. Let's make it 200. And I apply again. Sorry. To effect changes, I need to do something. So let me remove the create and press again. Now the software will know that we need to recreate. Okay, let's see what happened. The software took the area and divided it into a grid of 5 meter by 5 meter. These are 5 meter by 5 meter. In fact, this is the 5 by 5 meter. And in each corner of the grid, let's take this grid square. The grid created squares, and this is square number 59. In this point, the software calculated, this is the existing ground level, this is the design ground level. Sorry, opposite. This is the design ground level, this is the existing. You know that existing is much higher, 5 meter higher in this case. The difference is 4.73 meter. The same goes here, 4.87, 486. Take cut, do average, and multiply by 25 by 25 is 125. You'll get the total cut in square number 59. The same goes for 60, 61, 62. And the total is shown in this table. Each square, we see the cut and fill as it appears on the drawing. And the total volume appear here. Now, see, in this situation, there's a difference. It was 6,130, now it's 590, which is almost 100 on 6,000 is around 2% difference. Why is the difference? The different source is because before it was accurate, now it's calculated by the grid. And for example, look at this square. It has a point here, a point here, a point here, and a point here. But here in the middle, it doesn't know how to really affect it. Only interpolation from this to this. So this is it. In fact, I can even break down the grid into smaller, and then it would be more closer to the original figure which I got. Let's see now. All right, you see this is almost the same. It was 6,125, 6,070, it's 50, it's less than 1% different. But I need to again change the size. Sorry. Or even take it smaller. So this is how I calculated the volumes between two surfaces. Any question to what I've shown just now? You'll get a video recording of that and then you'll be able to practice. But my question, any questions about what I've just shown you? This is a very practical strength in the system that shows how to calculate volumes. In fact, every construction company that do day-to-day works of earthworks, cut and fill, along roads, along pit holes for buildings like I showed here, or anything else, they will need such land development, they will need such thing. Because they don't have any other method of calculating it. To calculate this by hand, it takes ages. Okay. The last method, because we're about to finish the lesson for today, is what we call frames maker. Frames maker. Now, okay, I have the calculation. Now I want to put this in a printing with coordinates and everything. How do I do it? In the general, I have a tool named Frames Maker. So I'm going to General, Frames Maker. It shows on the right. I'm starting by options, choosing the scale which I want to print, and the paper size. So I want to use 100 to 200, 1 to 250. This is the scale. I'm going to print it. And I want to print it on an A0, big page. Good. Now A0, I want to see the size of A0. So I'm pressing this button here on the right, locate frame on drawing. I'm going, I'll start here. I'm clicking here and enter. Oh. Doesn't work. Okay, I have to press escape. Here it is. You see it? This is the frame. This is A0 frame. A0 frame if we are printing to 1 to 250. So now I'll move it to right location. Here, this is what I want to print. I don't care about this one. I want to just print these volumes. So I'm fine. This is what I want to print. This is the area. This is an A0 at 1 to 250. Then I have to select this frame as my frame. I'm going to select here, click on it, and press enter. The system gives me the coordinates of the frame. If I'm happy, I'm pressing apply. Sorry. And press OK. Here it is. Everything is ready for printing. Just see you have a frame here. Let's give it, I don't know. And blue. Okay. Now my drawing is ready to print. This is my frame. The legend, we'll learn how to change it later on. We have the north arrow. We have the frame. This is a map. Now we are ready to print, or maybe I can add some more feature or modify it from here, or add my logo in the beginning. And this is it. The map is ready for printing. So regardless to the type of map, this is the powerful tool that every civil engineer needs, is to general frames maker and just create a frame like this to be printed. Any questions? Of course, it's in the paper space. Any questions? None. Thank you all, everybody. We will upload this and the formal lesson, and we share the share folder with all of you. Someone asked a question by typing. Let's see. Ah, just thank me. Nilo, are you from which company, Nilo? Infosys. All right. So I hope you enjoyed the training. And next one will be more on roads design. I think we're already starting road design next lesson. So everything is, I hope it was clear. And if not, like everything in life needs practice. So just repeat the movies and you'll get it. Thank you very much. Have a nice week. We'll meet next week. Cheers. Bye.